Here's a 10 by 10 grid that I made earlier. So in this question, we're basically trying to shade this grid as much as possible, but avoiding ever getting a 2 by 2 square like that. So we could just try some things out. Like we could shade all of the top row. That seems a good plan. But then I can shade that one, but I'm going to have to miss that one out. Miss that one out. Okay, but that's a lot of squares shaded, and it's hard to imagine how we could, for this part of it, how we could shade any more. And if we carry on that pattern, then we get this structure. Somehow I missed the very last part. Okay, just finish that bit off. Okay, so we can shade. Now there's one. How can we count this quickly? There's 1, 2, 3, 4, 5. Lots of 10, and then there's 5 lots of 5. So we can shade 75 squares and avoid a 2 by 2 grid, shaded grid, I'm going to call it. So it feels like the answer is going to be 76 because we're interested in the smallest number of cells so that there has to be a 2 by 2 grid. Wherever I put the next one on here, I'd have to get a 2 by 2 square. Question is, how do we show that for certain? That's the hard bit about this question. I'm going to try my best to explain it now. So the way I did it is I consider tessellating this structure. So we can fit at most, there's going to be so 3 here, 25 of these. There's going to be at most 25 of these into the square. So I've got 5, like this is 1, so I've got 5 in the horizontal direction, 5 in the vertical, so it's 5 times 5. Don't know why that took me that long. I can fit at most 25 of these into the big square. Which gives, this is a much quicker way, which gives 75 shaded squares. Any attempt to shade another square will result in this, a filled 2 by 2 square. So that's kind of like my explanation why we can't shade any more than 75 without filling a 2 by 2 square. Therefore, the smallest number of cells the ladybird must visit. Okay, returning back to the ladybird problem. So I should probably say a shaded square is where, I should have said this right at the start, is where the ladybird has visited. Therefore, The smallest number to guarantee a 2 by 2 shaded grid is 76. So that is my attempt to explain this question. I filled in a grid kind of intuitively, thinking about it to get like a lower bound, essentially 75. Not actually, 76 is the lower bound for the problem, but 75 was the lower bound for how you can do it without getting a 2 by 2 shaded square. And then I considered it as a tessellation and said we can fit at most 25 of these in. So any attempt to shade another one will mean that you're going to get a 2 by 2 shaded square. And then I just kind of linked it back to the ladybird problem. A shaded square is where the ladybird is visited. The smallest number to guarantee a 2 by 2 grid is therefore 76. So I hope that's enough. This is what the answers said. They said, since it's possible to use, well, they used ladybird symbols instead of shading. So we can use 75 and not get a 2 by 2 grid, then yeah, it's got to be greater than 75. And then they kind of argued along the similar sort of lines for why 76 will mean that it guarantees a 2 by 2 grid, and hence the answer is 76. So I think I've done enough, and I'll leave it there. Okay, well done.